In this video, we will solve another problem of a truss using method of joints. Method of joints is used when forces in all members are required to be found. Here we have to determine forces in all members. So we will start with a joint which is connected with two members. Now you can see joint E is connected with two members DE and BE. So we can start with E. We cannot start with A or C because these are pin connected and here reactions are unknown, and using rules of statics we cannot be able to determine reactions at these two supports. So we will start from joint E. So we will draw free body diagram of joint E. There is one force 40 kilonewton vertical downward and two members. So we will show forces along this member away from the joint E. So one member is BE. Now this angle is 45 degree. You can see that this is 90 degree, this is 90 degree, and these sides, this is 3 and this is also 3. So all these angles will be 45 degree. So this is 45 degree, this is also 45 degree, this is also 45, this is 45, 45, 45. All these angles are 45 degree. So angle of B is known 45 degree. Another member is DE, which is acting horizontally. So FDE away from E along direction of DE. Now we can apply sigma fx equal to 0 and sigma fy equal to 0, two equations of equilibrium here. So first we will apply sigma fy is equal to 0. So FBE, vertical component of FBE is FBE sine 45 positive and 40 kilonewton negative. So what you are getting, FBE sine 45 minus 40 is equal to 0. Therefore, FBE is equal to 56.57 kilonewton. Positive sign indicates tension member. Now next equation is sigma fx equal to 0. So this is FDE and this is FBE cos 45. Both are in negative direction. So you can take positive both. So FDE plus FBE cos 45 is equal to 0. When you solve this, you will get FDE is equal to, value of FBE is already known, 56.57, and solve this, you are getting FDE is equal to minus 40 kilonewton. Minus sign indicates this member is compression member. In next step, you can take either joint B or joint D. If you take joint B, there are three unknown forces in members AB, BC and BD. And BE is already known, but because of these three unknowns, we cannot take joint B. If you take joint D, there are three members, DC, it is unknown, so BD is also unknown, but DE is known. So only two unknown forces in DC and BD. So we can take joint D in our next step. So draw FBD of joint D. So there are forces 40 kilonewton vertical downward, force in FBD along vertical direction, DE along horizontal direction and CD along horizontal direction. So show these forces. So these are the four forces. Now you can apply equations of equilibrium. Sigma Fy is equal to 0. So FBD equal to 40 kilonewton. So this is sigma Fy equal to 0, and in sigma Fx equal to 0, FCD is equal to FDE. So FCD is equal to FDE. FDE is already known, minus 40 kilonewton. So FCD is also minus 40. So it is also compression member. Now we can take joint B. So let's take joint B. So there are four members AB, BC, BD and BE. So you have to show forces along these directions. So I have drawn FAB along this direction, then FBC along this direction, angle 45 degree, vertical direction FBD in vertical direction, and FBE again along 45 degree, FBE. Now you can apply sigma fx equal to 0 and sigma fy equal to 0. So what you will get? So sigma fx equal to 0, so FAB minus FAB, then FBC cos 45 negative, so FBC cos 45. Now FBD is 0, its component will be 0. FBE cos 45 positive direction is equal to 0. So in this we know value of FBE 56.57 and other two forces are unknown. So you put this value 56.57, simplify this. Again, there are two unknowns. You cannot determine these two unknowns at present. So what we will do, we will take sigma Fy equal to 0. So when you apply sigma Fy equal to 0, then FBC sine 45, FBE sine 45 and FBD. These three forces will appear. So FBC sine 45, its sine component, FBE sine 45 and FBD is equal to 0. Now here FBD is known, FBD is 40 kilonewton, FBE is 56.57 kilonewton and FBC can be determined. So FBC sine 45 plus 40 plus 40 is equal to 0. So FBE sine 45, when you solve this you will get 40. So solve this, you will get FBC as minus 80 divided by sine 45, that is minus 113.14 kilonewton, and minus sign again indicates a compression member. So put this value of FBC here in this equation. So this is negative, so both will become positive. And when you solve this, then you will get FAB as 120 kilonewton tension member. So in this way, you have determined forces in all the members along with their type of force, that is either tension or compression. So you can make this, or you can show all these answers in a tabular form with all forces and whether that force is tension or compression. These are the answers, required answers. Thank you for watching this video.